In this video, we are going to talk about geometric sequences. A geometric sequence is a sequence of numbers whose ratio between numbers is constant. Just like arithmetic sequences, we have two types of equations for this, a recursive and an explicit. They are set up almost the same way. In a recursive, you always have to give me your starting value. So let's say that's 3 in this case. So I'll just say a1 equals 3. And then the formula part is a sub n equals a sub n minus 1. So again, using that previous term, but this time I'm going to multiply by the ratio, and let's say 2 is our ratio in this example. To write that in explicit form, I just have a sub n equals your first term, which is 3 in this case, times your ratio 2 to the n minus 1 power. So what type of function does this explicit formula look like? An exponential. And the meaning of these terms are basically the same. A sub n is the term number desired. N is the number of terms. A sub 1 is still the first term, but instead of d, we have r, which is ratio. Alright, so in these examples, in this first one, I'm going to find the 8th term of this sequence. So I have 1, negative 2/3, 4/9. So the first thing I need to do is find the ratio. How I'm going to do that is I'm going to take the second number divided by the first number. So negative 2/3 divided by 1, negative 2/3. Then I'll take the third number divided by the second number, which again is going to give me another negative 2/3. You could also see maybe going forward that you're multiplying by negative 2/3. That's fine if you see that. For a lot of people, it's just easier to do the division, and so they take the second number divided by the first, the third divided by the second, so on and so forth, to be able to find the ratio. So in that case, I know my ratio is negative 2/3. I know my a sub 1 is 1. And I need to find the 8th term. So I can plug this into my formula. It's going to be a sub 8 in this case equals my first term times my ratio of negative 2/3 to the 8 minus 1 power. So you plug all that in your calculator, you get negative 128 over 2187. Alright, next. Suppose you want a reduced copy of a photograph. The actual length of the photo is 10 inches. So that is our a sub 1, because that's what I'm starting with, that actual length. The smallest size that the copier can make is 64% of the original, so that's going to be my ratio, but as a decimal, that's 0.64. And now I want to find it after 5 reductions. So the tricky part about this is a lot of people tend to write n is 5, but this says I want the length after 5 reductions. So I want it to have shrunk down 5 times, which means n is actually 6 in this case, because the formula is the ratio to the n minus 1 power. So if I want 5 reductions, I need n to be 6. So when I plug that in, I have a sub 6, which is my equal to my first term, 10, times my ratio, 0.64, to the n minus 1 power, 6 minus 1. And then that will give me 0.64 to the 5th power, which is those 5 reductions, which brings me to 1.074 inches after 5 reductions. And you can check this easily by just multiplying 10 by 0.64 5 times. So I have 10 multiplied by 0.64 is 6.4, 4.096, 2.621, 1.678, 1.074. So if this is a sub 1, then I have 1 reduction, 2, 3, 4, 5 reductions, which is my 6th term in this case. Alright, last example, I have to find the missing term. So like I did in the arithmetic sequence video, I'm going to re-index these. So even though 6 in this original sequence is the 2nd term, I'm going to say that's our 1st term. So that's going to be a sub 1. So I have 2, 3, 4. So that means 486 is my 5th term. So now I can work backwards to find what I'm missing. And in this case, I'm missing the ratio. If I find the ratio, then I can figure out how to get the next terms. So if I plug this into my explicit formula, I know a sub n, which is the 5th term in this case, is 486 equals your 1st term, 6, times your ratio, which is what I'm looking for, to the n minus 1 power, which is 5 minus 1. If I simplify that, to solve for r, I need to divide the 6 over first, which gives me 81, equals r to the 4th, and then I can take the 4th root of both sides, and you end up with r equaling 3. Now that I know r is 3, I can plug this back in. So if I start at 6, I get 18, 54, 162, 486, and I get the previous one before the 6. Well, the ratio is 3. I'm working backwards, so instead of multiplying by 3, I'm going to divide. You get 2 as your answer. And that's everything for geometric sequences. Let me know if you have any questions.